for n equals k plus 1, we can expect for cos theta plus sine theta to be to the power k plus 1. We can also expect, therefore, that we should have k plus 1 in here and k plus 1 in here. That is what we are looking for. That is the pattern that seems to be the case. However, let's instead analyze the left-hand side because we know this to be true. Cos theta plus I sine theta k would therefore be multiplied by 1 so that these two are equal. This cos theta plus I sine theta mod to the power k, we also know is true, as we've proven it in the past, that, for example, z equals r cos theta, and for cos theta plus I sine theta 1, we'd have cos 1 theta plus I sine 1 theta. We can simply say, well, for just a value of k, we should just have it come in front, like so. And I say we also know it to be true, but remember that actually that's somewhat of a lie. We've assumed it to be true for n equals k. We've assumed this pattern to be the case. Cos theta plus I sine theta I've just kept constant. Now let's analyze the algebra here. So I've taken this cos k theta plus I sine k theta, cos theta plus I sine theta, and multiplied it out. And I've taken my time to write out the steps to multiply that out. Notice our I squared has popped in here, which would produce the negative sign that I have here. That I squared is why I have a minus sine k theta sine theta, as is this part here. And I've also decided to collect, like I've done in the past, all the imaginary parts. So I factorized out I, leaving behind the cos k theta, the cos k theta sine theta, so there is what has been left here. And finally the sine k theta cos theta, so here we have the same situation. That is now there. And so I've separated my real and imaginary, synonymous to the separation of the real and imaginary on these axes. And I've removed the I squared, or converted the I squared into what it is equal to, which is minus. Now, let's consider, therefore, let's move slightly to the left here because we're moving out these equal signs. We can therefore utilize the same, or use this same cos alpha plus beta, cos alpha cos beta minus sine alpha sine beta, and notice its pattern is here. So we can simplify that down to just alpha plus beta. So in these circumstances, I believe we can comfortably say that this would be cos k theta plus theta. And if I had, for example, if I was to have, let's say, cos k theta plus theta, I could factorize out the theta, which is why I would then have this